Today we stand at the crossroads of sustainability. We can choose to ignore the warning signs, or we can choose to develop new technologies that will clean our air, purify our water, minimize our waste, conserve our natural resources, and power our civilization into a sustainable future. Someone once asked me, if you could save the planet, what would you do? My answer is labees. Labees stands for Laboratories for Engineered Environmental Solutions. Here we combine science and technology to protect and conserve our environment. The lab's mission is to provide access to scientific and analytical equipment for researchers as well as to train engineers in the environmental field. We're helping to create the next generation of engineering science educators, researchers, and innovators, a national priority.
Labees is an opportunity to use our research for environmentally friendly solutions and to take those solutions to the next level where they affect the lives of people every day. Labees is focused on developing new technologies and new applications that can be used to improve the quality of life and eliminate or prevent environmental contamination.
The work that I'm doing will bring practical solutions to businesses and the community, create green-collar jobs, and help people save money while conserving precious environmental resources.
Student researchers are involved in interdisciplinary activities that range from civil and environmental engineering, earth sciences, chemistry, biology, microbiology, and interaction with the private sector.
One of the most important challenges facing the engineers of the future is the concept of pollution prevention and sustainability. For instance, by using simple new technologies, how can people effectively reduce their consumption of water and energy? How can businesses improve their indoor air quality and minimize waste? Florida Atlantic University's Labees has partnered with academic institutions, regulatory agencies, and private industries to find answers to these questions.
Florida's coastal environments and coral reefs are particularly vulnerable to pollution. That's why Labees is investigating the sources of fecal bacteria in the water off our coast. With projects from the Keys to the Treasure Coast to the Gulf of Mexico and the waters off Taylor County, Labees researchers are investigating how sources of terrestrial pollution differ in rural and urban environments.
To aid us in investigating the sources of fecal bacteria and to ultimately better manage Florida's coastal oceans, waterways, and beaches, Labees is developing and testing new methods of source tracking. From pathogen counts to DNA markers to optical brighteners to chemical tracers to nutrient radioisotopes, these methods can be used to determine the impacts from septic tanks, drainage canals, ocean outfalls, and atmospheric deposition.
If we can track where the waste is coming from, then we can better target solutions that will help protect and restore coral reef ecosystems and aquatic life, as well as improve water quality.
Florida must deal with 35 million tons of municipal solid waste each year. That's about 10.5 pounds per day for each man, woman, and child in the state. About 65% of this material ends up in landfills. When it rains on these landfills, water comes into contact with the waste and forms a liquid containing hazardous pollutants such as pesticides, heavy metals, solvents, and other household chemicals that leach from the waste. This liquid, called leachate, must be disposed of properly or it will contaminate the groundwater, the source of our drinking water.
Unfortunately, we don't have technologies that can adequately address all of the contaminants in leachate. So the question is, can we develop innovative on-site leachate treatment technologies so that landfill operators don't have to haul the leachate in large tanker trucks to distant wastewater treatment plants in faraway cities? Labees is working with the Bill Hinckley Center for Solid and Hazardous Waste Management to develop futuristic treatment technologies to address these types of problems.
This section of the lab at FAU is affectionately known as the tanning salon. Here we use a powerful ultraviolet lamp to mimic the effects of natural sunlight as we work on developing advanced oxidation and photocatalytic technologies to create potent oxidants that can attack any contaminant in water.
One of these methods uses a catalytic technology which was developed to purify water for manned missions to Mars. Basically, the catalyst is activated by harnessing the power of the sun. It speeds up the decomposition reaction but is never used up in the process. So if successfully implemented, this research would be cost-effective and efficient for water purification without a huge carbon footprint.
Much of Labees' research involves taking natural processes and finding ways to use them to help solve local and global environmental problems. Using nature as a guide, waste management sites could become the fueling stations of the future.
Labees is researching the production of methane biogas at sanitary landfills and wastewater treatment plants. What if we could restore polluted water bodies that are choked off by nuisance algae growth? Here at Labees, we're looking at ways to harness that algae for the production of biofuels such as ethanol, biodiesel, and methane biogas to provide fuel for a community while cleaning up their nutrient-overloaded waterways at the same time.
Excessive nutrients aren't the only contaminants that are polluting our natural environment. The restoration of the Everglades is happening in our backyard. The Florida Everglades is one of the world's largest and most diverse wetland ecosystems. This delicate natural preserve is threatened by contamination from nutrients, pesticides, and chemical endocrine disruptors. These pollutants cause adverse biological effects at levels too low to be detected by today's best analytical technologies, so there is no easy method to measure how the restoration process is working. Labees is developing a biological assay, essentially a scientific experiment that can detect the effects, if not the presence, of these contaminants and their interactions with other pollutants.
The United States Environmental Protection Agency developed a standard protocol for aquatic toxicity bioassay testing using multiple species and multiple endpoints. Here at Labees, we've built a portable bioassay testing platform that can handle multiple species using the same environmental conditions with reproducible results. We can even adapt the system to use native species that are more relevant to our local ecosystem. We're one of only a handful of laboratories in the United States equipped to conduct this type of testing.
We're working on more research activities at Lab East that focus on a wide variety of new technologies for the environment. Technologies like green buildings and structures that consume less electricity and water, simple and inexpensive hybrid car retrofits that run mostly on natural gas and use only small amounts of gasoline, cost-effective disposal of potable water desalination brine concentrate without harming the environment, community composting systems that partner waste haulers, local restaurants, and local commercial plant growers in using new small footprint, odorless composting equipment that can turn waste into mulch in a short amount of time.
We're doing this conservation research in the interest of society.
We have the tools and the infrastructure in place to reach our goals and to bring about real change.
This is an exciting time to be a part of the research here at Labees. It will have a tremendous impact on Florida and the world.